Another video of my channel Fern Learning. Today I'm going to start with the very basic concepts of chemistry, that is atom, and we are going to discuss its structure. So I'm going to start with the understanding of the word atom and what does it mean, and what are the subatomic particles present inside an atom and what are their characteristics. And once you know the subatomic particles, their number, their characteristic, you would be able to identify the element. So let us begin first with the understanding of an atom. Now, what is an atom? Atom is the smallest particle of any matter which may or may not have independent existence. That means we cannot further divide an atom, but this concept was given initially when the scientists started studying the matter, how the matter is made. Now we know that we have 5 states of matter right now: solid, liquid, gas, plasma, Bose-Einstein condensate. So irrespective of any matter, everything is made up of atom. But later on, the scientists were succeeded to find out what is present inside an atom, how an atom look like. So there are some particles are present. That is what we are going to study now, that is atomic structure. So before that, how we define an atom? This atom which may or may not have independent existence means they can exist independently like in noble gases, or mostly they cannot exist independently. They form compounds and molecules. They exist like gas, hydrogen gas, oxygen gas, sodium chloride. So that is how it's occurring in the nature. Now let us look at the particles which are present inside an atom. So there are 3 particles present: proton, neutron and electron. But how these particles are arranged inside an atom? So let's look at this slide now. We can see here, this is a structure where in the middle, there you can see the 2 color balls. One is blue, one is orange. Blue one is representing neutron and the orange one is representing proton. So you can see in this structure, it's like similarly it looks like solar system, where sun being present at the center of the solar system. Here we say the nucleus is present within in the center of an atom, and in that nucleus the 2 subatomic particles, proton and neutrons, are present. And outside there are imaginary paths in which the yellow color balls you can see, these are representing electrons. They revolve around these nucleus. So these are the 3 subatomic particles location within an atom. Now what are the charge of these particles? Proton is positively charged particle. Neutron is the neutral, it carries no charge, and electron is the negatively charged particle. So what happened when any atom, irrespective of any type of element, it contains the same number of protons and electron. So what happened? This atom becomes neutral as the number of proton and electrons are equal. That means if I say atom is neutral, why? They contain the same number of proton and same number of neutrons. As the same number of proton and neutrons, because this charge, the plus will cancel off the negative charge, so it will become neutral. Now let us look at this mass and charge. Now charge we already discussed. Now look at the mass of these 3 particles. If we compare the ratio of the mass, proton and neutron, they carry all the same mass, but electron mass is negligible. So if we say the mass of an atom is contributed by the 2 particles which are present inside the nucleus. And what the particle present inside the nucleus? Proton and neutrons, and together they are known as nucleons. So we say whatever the mass, if we talk about the mass of an atom, it is basically the mass of nucleons we are talking about, because electron mass is negligible. Now next we have this atomic number and mass number. These are the characteristic terms. Now atomic number, it is the number of protons found in the nucleus of an atom. So if an atom has 5 proton, it is the atomic number will be 5. It is denoted by the letter Z. And mass number, as I said, Mass is contributed by the nucleon number, which is the total number of proton and neutrons inside an atom. Okay, so these are the two: atomic number and mass number. These are the characteristics that will be always used when we talk about atoms and their characteristics. So if we'll apply how, if we know the element, and how do we symbolic representation of any atom will represent. So like suppose this X, there are a different representation of each an element, like hydrogen, oxygen is O, hydrogen is H, carbon is C. So if we know the chemical symbol of the element, now here it is represented as X. Now superscript, you can see it is Z. Now Z below you will write down, that denotes the atomic number. That means the number of protons, and the superscript is the A, which is the mass number or the number of nucleons present inside. So if we know the symbol of the element, we know the mass number, we know the atomic number, we can represent the atom in this form. Now let us apply to different atoms now. Now hydrogen, as we know, hydrogen symbol is H, atomic number is 1, mass number is 1. Then what will be the representation? It will be H1 and H11. So what you can infer from this representation here? Can we find out the number of electron, proton and neutron? So what is unique here? You can see if atomic number is 1, what does it mean? It has 1 proton. If mass number is 1, that means it has again 1 proton. There is no neutron. So there is a question based on this: which particle is not present in hydrogen atom out of 3, or which subatomic particle is not present? So we can say very easily by looking at the atomic number and mass number, it is the neutron which is not present, as its mass number is 1, which is contributed by its 1 proton, and its atomic number is 1. So this is how we are going to answer these reasoning questions. Now let us look at the helium atom now. Helium representation is He. It's 2. You can see again the number of protons here. 4 is the mass number. Now we can see here how they have shown in the structure. This is again 2. This is a nucleus here where they are shown plus. That shows the 2 protons, and then blue color balls, again it is shown for the neutrons, and these outside the nucleus there are 2 green color which is representing electron. So this is how the representation of helium atom. Now let us look at the lithium now. Lithium symbol is Li. Its atomic number is 3, mass number is 7. So we again represent that. If I'll say atomic number, what is it automatically? You will understand it's the number of protons. If I'll say atomic mass, it means the number of proton plus neutron together. So we can identify that how many electron, proton and neutron by looking at the atomic number and mass number of any atom. So let us look at the example here, like chlorine 1735. So by looking at this representation, what are the features we can state? So we can say its atomic number is 17, then its mass number is 35. So if atomic number is 17, that means the number of protons are also 17, and if number of protons are 17, number of electrons are also 17. So protons and electrons are always equal in a neutral atom. Number of neutrons. Now what we are going to do here, the mass number minus atomic number will give the number of neutrons, or in simple words, number of neutrons you can get by the total mass minus number of protons. So we are getting here 18 is the number of neutron. So now we can apply this to complete the table. Here we can see there are 3 unknown elements P, Q, R, and there are some characteristics are given and remaining you have to fill. Now we will look at the P here, which is mass number and atomic number are given. So what will be the proton number? By looking at the atomic number, we can say it will be 7. If the protons are 7, electron will definitely be 7. And what is the number of neutron? 14 minus 7, so it will be 7. Now similarly we can do it for Q. The mass number is given and number of protons. Now what is atomic number denotes? It denotes the number of protons. So we can say the atomic number is 11. Now number of electron, again the protons and electrons are always equal in number in an atom, and neutron will be 23 minus 11, it will be 12. So it will be 12 here. It's not written properly. Then again we say mass number 40. And here what are the, can we find out what are the others present here? No, because only mass number is given which is together. So there should be one more thing, one more characteristic must be given to complete the table. So this data is not correct. Only one mass number is given, so we cannot identify the subatomic particles on the basis of one characteristic which is mass number. There should be atomic number or proton number must be given. I hope you understood the atomic structure. If you have any query, please post in the comment section, or if you want any other topic to be explained, that also please post in the comment section. Thank you.